All right, moving on to chapter 5. So we're talking about the skin, the nails, hair, etc. today. Okay. Uh, okay, so the skin. It's our largest organ. It accounts for 7% of the body weight. Like people usually think the liver is the largest organ, but it's not. It's actually our skin. Okay. Our skin is subdivided into two distinct layers: the epidermis and the dermis. Okay, epidermis on the surface, and then underneath it, the dermis. Okay, underneath that is the hypodermis. The hypodermis is not actually part of the skin, but usually in anatomy we teach it as part of the skin because, well, it's closely related, but it's it's right there, and there's no other place to really shove it into. Okay. Okay. So here is the skin. So epidermis, dermis, and then this fatty layer underneath is the hypodermis. Okay. Okay. So you can see this on a cadaver right here. The epidermis, underneath it is the dermis. Underneath that is the hypodermis. Okay. And then the deep fascia, and then actual muscle. Okay. All right. First things first. Number one, and by far the most important thing of the skin, is to cushion the organs and protect from bumps, chemicals, water loss, and UV radiation. Okay. Okay. So your skin, okay, protects the rest of your body, right? So it separates you from not you, like I said earlier. Okay, it's also waterproof. Okay, so you put water on the surface of your skin, the water is not going to get in. So all right, so I'm not sure you can see that there, but anyway, okay, the water stays on the surface of my skin and it doesn't get in, and that's very important. Okay, because if I jump into a swimming pool or a pond or the ocean, I don't want whatever's in the ocean to enter my body. I definitely don't want whatever's in the dirty ass pond to enter my body. Okay, so it's very important for your skin to separate you from not you, and that's why if you have a cut, that makes a big, huge difference because now that cut allows an entryway for stuff. Okay. And also equally important, I don't want water to get out through my skin. Okay, a little bit will because you'll sweat and stuff, but you want to keep the moisture on the inside and you don't want it to dry out. Okay. All right. It also controls body temperature regulation. Okay, we'll talk about that in a little bit. We'll talk about excretion, the production of vitamin D. Okay. Your body needs a little bit of vitamin D every day. Okay. And we use UV radiation to synthesize vitamin D. Okay. So in Southern California, that's not really a problem. Okay. You need about 15 minutes of sun a day, maybe even less. Okay. And last but not least, sensory reception. Okay, we have a lot of receptors on the surface of our skin that help us feel pressure, pain, okay, and other stuff. Okay. Okay. All right. The epidermis, okay, is composed of keratinized, stratified squamous epithelium. So stratified squamous, many layers of flat cells, keratinized, they're filled with keratin, which means they're dead on the very surface. Okay, so it contains 4 major cell types. Keratinocytes are by far the biggest one. Okay, this is the location. This around Minosum. There's keratin. Okay, don't worry about these words later. You'll understand what they are in a little bit. Melanocytes produce pigment, in particular melanin. Okay, the tactile epithelial cells, they're in the basal layer. They attach to sensory nerve endings, so we have a feeling of touch and sensation, okay, and pain coming through those layers. Okay, and last but not least, the dendritic cells. The dendritic cells are in the surrounding Minosum. They're part of the immune system. Okay, so as a early warning signal to the immune system, these dendritic cells, they sit right in that layer, okay, and they eat up any viruses or bacteria that enter that layer. So by the time they enter through that layer, they're almost through the skin. So that tells the system that you're infected by this thing. And so your immune system can generate a response to this thing before all hell breaks loose. Okay. Keratinocytes are the most abundant cell type in the epidermis. They arise from the deepest layer of the epidermis. Okay. And they produce keratin, a tough fibrous protein. Okay. They also secrete a lot of antibiotics and enzymes that are determined to keep your skin surface relatively clear of microbes. Not all the way clear, you can't do that, but relatively clear of microbes. Okay. Again, it is really important that the keratinocytes on the surface are dead. The reason why that has to be true is if keratinocytes are not dead, then you can get an infection right on the surface of the skin. And that will happen all the time because there's a lot of microbes everywhere. Okay? Having dead skin on the very surface allows protection. Okay? All right. So the layers of the epidermis. Okay? Stratum basale, stratum spinosum, stratum granulosum, stratum lucidum, that's only 16, stratum corneum. Okay, so these 5 layers, this is bottom to surface. Okay, so the surface of your skin is the stratum corneum. So let me teach you a mnemonic. Let's get okay. So corneum, lucidum, granulosum, spinosum, basale. Okay, so this mnemonic works from outside in. So most outside, corneum. Then if you have it, lucidum. Get, okay, granulosum, S, spinosum, B, basale. Okay. Oops. Okay. So here you can see stratum basale here. Stratum basale is the deepest epidermal layer. It's only one single layer of cells. Okay. It's also known as the German Sebum. Okay. So the basale means basal, the bottommost layer. German Sebum means the germinating layer. Okay. Germinate is when you grow. Okay. So this layer of cells will grow another layer, and one of them will stay behind, and one of them will go through all the stages to eventually end up on top here. So this layer is the layer that grows the most. Okay. Okay, so the next layer up is the Minosum. Okay, several layers of keratinocytes. Okay, they're starting to make something called pre-keratin. Okay, the next layer up is the Granulosum. Okay, 1 to 5 layers of flattening cells. The cells are actively dying in the granulosum. Okay, so above the granulosum, they're dead. Below the granulosum, they're alive. In the granulosum, they're actively dying. They're actively committing suicide. Okay, and they literally do. It's not just they die. It's they're actively killing themselves. And one of the things they do before they kill themselves is to make sure to destroy their nucleus. Okay, so moving up top, there's nothing to infect. Okay, and then you have the corneum. Okay, the corneum in thin skin is only 20 to 30 layers of dead cells. Okay, now if you look at this carefully, you realize I skipped one layer, and that is the lucidum. Lucidum is only in thick skin. Okay, thick skin is only found in 2 places: the palm of your hands and the bottom of your soles of your feet. Okay, okay, so sorry. So this is thick skin. Oops. This is thick skin. Okay, the thick skin. Do you see how the corneum is much, much thicker? Okay. In addition, it has a clear layer called a stratum lucidum. Okay, so a couple of things. The palm of your hands and soles of your feet, they are the ones that come into contact with stuff the most. And therefore, you need more layers of dead skin on top. Okay, so you have a thicker corneum, so thick skin. Okay, like you can immediately look at your hands, look at it back, look at the skin on the back of your hands, and look at the skin on the palm of your hands, and you can immediately notice a difference. Like you can even notice a difference in color, especially if you're darker skin. You can notice a very distinct difference in color. And if you look even more closely, you have hairs and stuff on the surface here, okay, but you have no hairs on this surface. Okay, and it feels different too. Okay. All right. So stratum basale, we've been talking about stratum spinosum, about okay. Okay. This one we actually been talking about as well. That granulosum is a different separation between dead and alive. Okay. So above the granulosum, they're too far to receive nourishment, so they're actively dead. Okay. So this is the lucidum. Okay, only thick skin, again, thick skin. Palm of your hand, soles of your feet. Okay. Hold on 1 second. Okay, sorry about that. Need to do a little something. Okay. Okay. So last thing to cover the corneum. The corneum, okay, it's literally dead keratinocytes. And we lose layers of corneum every day, and they grow back from the germativum or the basale layer, and that's what they're for. Okay. All right. So the second portion, okay, The second region of the skin is the dermis. The dermis is flexible, strong, flexible connective tissue. Okay, if you look at your wallets or leather purses, okay, that is dermis. Okay, if you take it, you realize the leather is flexible but strong. Okay, that is what dermis actually is. The leather in your wallet is the dermis of a cow, hopefully, or crocodile occasionally. Okay, it is strong, flexible, connective tissue. It's richly supplied with blood vessels and nerves. Okay, remember the epidermis is epithelium, so there's no blood vessels to there. Okay, the dermis is where the blood for your skin goes through. Okay, so I'm gonna go back to this picture. Okay, so now we finished talking about this layer. Now we're talking about this layer here. Okay. So realize there's no blood vessels until here, right? So everything below, everything we talked about, there's no blood vessels. Okay. Okay. The dermis has two layers. Okay, the papillary nervous, which includes the dermal papillae, the little bumps, and then the reticular dermis. Okay, the reticular dermis is the vast majority of it. Okay. Okay. The dermal papillae, you'll see the dermal papillae. Sorry, let me show you this picture again. The dermal papillae are these little bumps right here. Okay, so by doing this, they increase the surface area between the dermis and epidermis. Okay, and that way it is able to get nutrients to the dermis, so it's easier to get nutrients from the dermis to the epidermis. Okay. The dermal papillae, also known as dermal ridges, okay, these can create something called epidermal ridges or friction ridges. These friction ridges are also what we know as fingerprints. Okay, fingerprints, what their purpose is to increase the surface area. Okay, and we need more surface area because the more surface area, the more we can grip. Okay, the tighter grip we can get. Okay. And we need our hands and feet, obviously. Okay. The reticular dermis, okay, accounts for 80% of the thermal thickness. It is made out of dense, irregular connective tissue. Okay. The papillary dermis is actually loose areolar connective tissue. The reticular dermis is dense, irregular connective tissue. So you have a lot of collagen fibers that run in every direction, which gives the skin strength. But, okay, there are cleavage lines, okay, and that is the separation between collagen fibers. Okay, so let me show you what cleavage lines actually look like. Okay, those are cleavage lines. Okay, those are the ways that the general direction of the collagen fiber actually runs. Okay, so here, okay. Usually, one of you guys in class is my victim for this. Oh, whoops, crap! I just realized I wasn't sharing my presentation. Hold on. Okay. Good thing I didn't really get into too much. The papillary nervous, the reticular nervous, Okay, so now cleavage lines. So here, okay, is the person, the cleavage lines. See how this person, okay, see how this person, the cleavage lines run here? Okay, so if I was to cut into this person, I could do one of two ways. Okay, I could use cutting it blue. I could either cut that way, where I am perpendicular to the cleavage lines, or I could cut this way, where I go along with the cleavage lines. Okay, since the collagen fibers run this way, if I cut through this way, I'm cutting into the collagen fibers, and therefore, when the wound opens, it stays open. Okay, and that makes it really hard to close and seal up on its own. Okay, so bad, much worse injury. Okay, on this side, I'm going along the collagen fibers. So the collagen fibers aren't cut, I'm just cutting alongside them. So the wound will seal naturally. It won't gape open, it will just seal naturally. And therefore, it's easy to stitch them together, and it speeds up recovery time. Okay, so like it's really important to cut, like, you know, assuming you don't want to cause this person unnecessary pain, it's very important to cut along the lines. Okay, does that make sense? All right. There. All right. The flexion lines, they anchor in deeper structures, and therefore you can see them when you flex. Like when you flex, you're flexing along the line. Okay. Okay. Hypodermis. Hypodermis is deep to the skin. So hypodermic needles, the purpose of hypodermic needles is to inject into the bloodstream in the hypodermis. Okay. They anchor the skin to the underlying structures. They help insulate the body. So the hypodermis is a lot of fat. Okay. And this fat, this hypodermis, has different distribution in males and females. Okay. So males and females gain weight differently. Males tend to gain weight around their waists. Okay. Females go slightly lower than that, so like hips and thighs, right? That's where a lot of females put on fat and stuff in the hypodermis. Okay, the hypodermis does have a function. I mean, you need it to help insulate the body. Okay, so losing the fat in the hypodermis actually can cause you to become really susceptible to cold. Okay, in humans it's not such a big deal, but in things like whales and stuff, or polar bears and stuff, that thick layer of hypodermis is what keeps them warm. Okay. Okay. So skin color. Okay. There are three pigments that contribute skin color. Okay. Melanin. Okay. Keratin and hemoglobin. So melanin is the most important pigment. It's made from tyrosine. Every one of us has the same number of melanocytes. Okay, per square inch or whatever. What makes us different is the amount of melanin that's produced. Okay, and a little bit about the shade of the melanin that's produced, but more importantly, the amount. Okay, and that's the difference. That's really the difference between us, and that's why, like, literally, people say the difference between humans are literally skin deep, and this is why. Okay, so the reason we produce different amounts of melanin is this. Okay, humans originate from Africa, roughly about 200 to 100,000 years ago. As we left Africa, Okay, Africa, there's a lot of sun. And if there's a lot of sun, then we don't need a lot of UV rays to make vitamin D. Okay, we do need a lot of dark skin because the melanin helps block out the UV. Okay, as we left Africa, we went north. And as we went north, north has less sun. Okay, and this is especially true of Europe. Europe has a lot of cloud cover and less sun. And because it has less sun, there was less UV. If there's less UV, and we run the risk of not getting enough UV. So what happens? Our skin gets lighter because lighter skin allows more UV through. Okay, so lighter skin, less UV, right? So that's why that became more dominant in Europe and Asia. Okay, and so you'll see patterns of people getting darker skin as they move south. So as we move south, as we move into Asia and move south, Indian populations also have really dark skin. Okay, and that's for the same reason. Now they're moving south again. Now there's more sun again, and they need more protection from UV. Okay, this is why also if you have light skin, you're at higher risk for skin cancer because there's too much UV coming through your skin. Okay. All right. So that's melanin. Keratin is a yellowish pigment that we pick up from carrots and tomatoes and other fruits and stuff. Okay, so in case you guys haven't realized, I'm Asian, okay? And we have yellow skin, okay? The reason why our skin is more yellow is simply because we pick up more keratin, okay? We have a slightly thicker corneum, and that allows us to pick up more keratin, and therefore our skin appears more yellow, okay? Hemoglobin, okay? Caucasian skin contains very little melanin. The hemoglobin is actually blood, okay, coming through. All right, skin color is really important in diagnosis. Okay, so cyanosis, okay, cyan is blue. So your blood is very, very bright red. When it's oxygenated, it is darker blue or reddish, bluish tinge to it when it's not oxygenated. So when you suffer from cyanosis, when you don't have enough oxygen, then your skin turns blue. Okay. Eurythmia is redness, red skin, fever, hypertension, inflammation, allergy. Okay, blood coming to the surface. Okay, if there is no blood, okay, not just low oxygenation, but no hemoglobin or lack of hemoglobin or red blood cells, you're going to get anemia. Anemia is white, right? The pale, the blackened white skin, low blood pressure, etc. Okay, jaundice is a sign of liver failure. Okay, jaundice, your skin turns yellow, and not just like Asian yellow, but yellow. And you can see it even in the eyes. Okay, and that is a sign of liver disorder. Okay, and bronzing is inadequate steroid hormones and Addison's disease. If you want to look, find pictures of JFK right before he died. He had Addison's disease. You can see like his skin is really weird looking. And then bruises. I'm sure you guys know what bruises are. All right, nails. Okay, are scale-like modifications of epidermis. Okay, so we are this thing called primates. Humans are in this thing called primates. So along with monkeys and chimps and gorillas and stuff, we are primates. That means we all have nails, okay, instead of claws, okay? So the parts of the nail, free edge, root, okay? So here's the parts of the nail. All right, hair, okay? Again, hair is a flexible strand of keratinized cells, okay? Dead cells. So everything above, like everything that comes out of your scalp, this is all dead tissue. All the living cells are actually embedded in the scalp, okay? So you have a root, you have a shaft, okay? I'm gonna skip the medulla, cortex, cuticle, etc. Okay. Okay. So here is the shaft. Okay. Here is the root and the bulb. The bulb is where all the living cells are. Okay. This is all dead cells. Okay. Okay. One thing I want to point out about this picture. Okay. This is the epidermis. This is the epidermis. See that the hair, that your hair actually grows out of the epidermis. This hair shaft, okay, this whole thing is actually epidermis. It has just been pushed into the dermis. So all of this is considered epidermis, okay? Don't mess that on the test, okay? And you'll see that on the, I'm gonna go all the way back to the very beginning, okay? Your hair shaft, your sweat glands, okay? They are all part of the epidermis, okay? They're, even though they're embedded in the dermal layer, they're from the epidermis in, okay? So we'll skip the structure of the hair, okay? Okay. The Retinal Pili, okay? The Retinal Pili are these little muscles right here that hold, that attach to the shaft, okay? So the hair stands erect when the Retinal Pili contracts, okay? So why is this important? What does this do? Okay. So the reason why it does this, okay, is simple. Your Retinal Pili holds your hair straight under two conditions. One is when you're scared, okay? Two is when you're cold, goosebumps, right? This is the goosebump response. Okay, let me tell you, the goosebump response has no effect on humans. Not zero, zilch. It doesn't do anything. But it does on other mammals. Okay? So think dog for a second. So picture your cute little dog. See what happens when it's scared. All its hair stand up, and now it's bigger, puffier, and looks about 100 times more dangerous than it did before. Okay, that is the purpose of the Retinal Pili. The other thing, the cold thing, same thing. When the hair sticks out like that, it traps heat a lot better, and therefore the animal stays warmer. Okay, in us, it's a useless response, but in other mammals, it works. Okay. Okay, so we'll skip the terminal hairs and villus hairs. Okay, the sebaceous glands. Sebaceous glands secrete sebum. Sebum is what we commonly call the oil, like on our faces and stuff, the oil. Okay? The function of the sebum collects dirt, softens and lubricates the hair and skin. It also has a lot of antimicrobial properties that protect the skin from microbes. Okay? Your sebum, your sebaceous glands, usually get increased activity, okay, during puberty. And you have to remember puberty. Puberty is when we get all these pimples and stuff. A pimple is actually just a blocked sebaceous gland, and the oil can't come out, so it's clogged and swollen and infected. Okay. That's why you pop the pimple and oil comes out and stuff like that. Okay, sweat glands are widely distributed throughout the body. Okay, sweat gland is a blood filtrate. It has 99% water with some salts in it and a little bit of urea. Okay, so you sweat out urine as well as pee it out, but it's very little. Okay, but if you go put on a white t-shirt, like the little like white beaters that people wear under the and go run, okay, for a long time and get all sweaty, you'll see that the shirt turns slightly yellow. That slight bit of yellow is the urine. Okay. All right. So again, sweat glands, just like the hair follicles. Okay. So sweat glands, sebaceous glands, they come from the epidermis in. Okay, there are two types of sweat glands: eccrine sweat glands and apocrine sweat glands. Eccrine sweat glands are all over your body, okay, and they produce true sweat. Okay, your apocrine sweat glands are confined to axillary, anal, genital, and perianal areas. Okay, and they produce a special type of sweat. Okay, apparently it works in other animals, but it doesn't really work in humans. The musky odor attracts mates and stuff like that. Okay, it signals about the major person's immune system, etc., etc. Okay, this is the musky. This is the bad smelling type of sweat. Okay, and let me explain how this works. So, this type of sweat is not just pure, mostly water. It's water combined with fats and proteins. Okay, that come out. That mixture by itself does not actually smell. But there are bacteria all over your body. Okay, the bacteria in this region of the body, there's a lot of moisture in this region of the body. Okay, there's more moisture than everywhere else. And because there's more moisture than everywhere else, there's more bacteria living here. And they're getting fed all this protein and fats. Okay, and so it's a feast. And their byproducts are what causes the smell. Okay, or what we commonly call body odor. Okay, that's why the body odor smells worse. Okay, in your armpits and your groin, etc. Okay. Okay. We have modified apocrine sweat glands in two locations. Okay, ceruminous glands and mammillary glands. Ceruminous glands are the glands that secrete what we call earwax. Okay, mammillary glands produce milk, right? So, okay. All right, the burns by severity, first degree burn. Okay, upper epidermis is this burn. Second degree burn, the upper part of the dermis is also damaged. This is where you can start getting blisters. So, first degree, okay, epidermis only. Second degree, you go past the epidermis, okay, you can get blisters. Blisters is what a blister actually is fluid accumulation between the epidermis and the dermis. That's why there's usually no blood in the blister. Okay, the blister is usually clear fluid that separates the epidermis from the dermis. Okay, and a third degree burn. So second degree burn is what hurts the most. Okay, third degree burns consumes the entire thickness of the skin, so you're burning through the skin. If you're burning through the entire skin, you burn away all the nerves, so you're not going to feel anything during that location. Okay, the burn area appears red, white, or blackened. There are things that are worse than third-degree burns. You're just not alive. Okay, so yeah, you can see the third-degree burns. Okay. Here they show you something called the rule of nines. Okay, the rule of nines, they break up your body into lines. Okay, you can see that here. Okay, skin cancer. Okay, skin cancer breaks down the basal cell carcinoma, squamous cell carcinoma. These two are by far the most common, but they're also the most least malignant. Okay, the most nothing to worry about stuff. Okay, the most dangerous is melanomas. Okay, so this is a melanoma. So like if you see a big spot like this, like that, especially if it's raised or if there's different colors to it, that is really dangerous, and you should see someone about that. Okay. Okay. So we'll skip the skin throughout life. Okay. Except this one. Okay. We have another layer of hair that's only in utero, and it's called the nougat. Okay, it keeps the fetus warm. Okay, that's why if you're born premature, you can still have the nougat on you, and therefore it looks hairy. And like I remember my niece came out about a month premature, and she like you see the hairs like over her ears and stuff like that. It's pretty cool. All right. So as you get older, the skin things becomes less elastic. One of the kind of ways to measure how physiological you are is to measure your skin. If you pinch your skin and let go, you'll see the skin bounce back right away. Okay, as you get older, that response slows down because you lose more and more collagen and elastic fiber, so the bounce becomes less quick. Okay. All right. So that ends this presentation. Okay. And I will see you guys. Okay. So I will see you guys next week. This is the only lecture I'm doing this week, actually. Okay. So this material, everything before this, is going to be on the first exam. Okay. Okay.